Okay, let's get started, shall we? Good afternoon, everyone, and welcome to this 13th lecture of ITI 1121. As promised, we're going to be going over some past exam material to just get prepared for our upcoming midterm on Saturday, later this week. As you might have noticed, I have already posted some practical information on Piazza. Please make sure you know where you're going to be going on Saturday. It's going to be one of these lecture halls in this corridor in the site building, ground floor. The way you should determine which room to go to is based on the first letter of your last name. All the details are on Piazza already. Please make sure you bring a piece of ID and whatever stationery you need. You're not going to be allowed to take anything else with you when you're taking the exam. So all electronics will have to be stowed in your bags and put in front of the class. No aids allowed. Make sure you don't have anything on you because anything that you may even mistakenly forget in your pockets, like a phone, it could be treated as plagiarism. So please be very careful with this. Yeah, so that's pretty much it in terms of practical matters. Again, I'll open the floor to your questions before we get into, one of these past exams. Specifically, I want to go over the written part of the 2025 exam. Just a bit of clarification. The way we are going to do these questions is going to be different than what you're going to see on the exam, in particular, because I want to give you a little bit more time to study for the written part, which has more weight. I'm going to be going through the written part, the practice exam for the written part first, and only on Friday do we get to go over the multiple choice part. So we're going to practice for that too. But for the actual exam, when you start working on the answers, you're going to be answering the multiple choice questions first. So there will be 10 multiple choice questions followed by 2 written questions. And it's going to be very, very similar to what you're going to see, but the order is going to be different. Why am I doing that? Because as I told you, I want you to have a heads up for the written part. This takes more practice. For the multiple choice part, you can, if you have time, the material I'm going to be going through has already been posted on Brightspace. So there is a video from last year going through the very same exam, as what we're going to see on Friday. I understand that Friday late afternoon is going to be probably too late. So if you want to get a head start on the multiple choice part, you can use that video as well. Okay. Yes. So for the multiple choice part, what we have done is to try to make sure that all the conceptual elements that we have gone over will be quizzed. So because the quiz is rather thorough, it's of course only 10 questions, but it basically quizzes you on all these bits and pieces that we've seen. What you can do is to make sure you understand the concepts behind any one of these questions that you see on the multiple choice part, and expect some sort of adaptation of the same kind of questions on the midterm, because we basically, this is something I can share with you because our questions pretty much cover everything. And if you understand what is going on in these questions that you will see and are able to replicate that, for similar questions, I think the learning objectives will have been achieved. So try to make sure you understand what is going on with the multiple choice questions. For the written part, please pay a lot of attention to what we're going to be doing, in particular to the first question that we're going to do together, the equals method for an array container. This is an important question. It has some twists and turns. And my hope is that if you're able to do this question from last year's exam properly, you're going to also be doing quite well, at least on a similar question that might be on the exam. Okay, so please pay a lot of attention to what we do today, and I'm sure this is going to serve you well. You need to be able to replicate this logic if need be. Any questions before we start solving last year's written part, please? No. This well, those are the challenge questions. You know, these are from the first attempt that we had at having multiple choice questions. And I acknowledge that we might have underestimated how much time it would take for one to read through all the options. We have learned our lesson. All questions will have A, B, C, D, E. And we have tried to minimize the amount of reading you have to do. So we are quite conscious. And this is why, you know, I've just put those questions, you know, for practice. Don't expect, you know, something, you know, too heterogeneous in terms of the options you have. Everything is going to be A, B, C, D, E, and the amount of, you know, reading you have to do, as I said, we have tried to minimize. Any further questions before we dig into the 2025 written part? No further questions. Are you all ready for Saturday? And yes, please do not be late. Okay. Yes, on that note, what usually happens is that once everybody is seated, once the dust settles, I'm not going to be waiting until, you know, 1 o'clock sharp to start the exam when, you know, everybody is available and, you know, 90% of people are here. We are going to get started to give you a little bit of extra time. Why do we do that? Because, you know, there have been occasions where we get kicked out right at 3 o'clock. You know, I do not want, if that happens, I do not want you to, you know, have 1 hour and, you know, 58 minutes instead of 2 full hours. So we will start. Do not be surprised if you come right at 1 o'clock and, you know, people are already working on their exams. So please do not be late. Let me see if there is any other practical thing I need to say. I wanted to say something. If it comes back, I'll tell you later. Yes, so for assignment 3, this is already there to post, but I have not done that because this is not the best time to focus on A3. I will post the solution to assignment 2 later this evening. If you want to have a look at that to make sure you understand all the necessary concepts, by all means. But assignment 3 will have to wait until after the midterm. So spend as much time as you can on the midterm, and let's worry about assignment 3 after we are done and over with our midterm exam on Saturday. Good. So what I'm going to do now is to go through the 2 written questions we've had in a previous exam, more specifically the most recent one from 2025. And without further ado, let's get started. Yes. So not surprisingly, and as I've told you a number of times, this equals method is quite important. And this is a frequent type of question on our midterms. So in this question, let me start this highlighter. You're going to do an equals method. What I suggest you do before you start writing any code, try to calm your nerves. Try to read through the question as carefully as possible before you start writing. So what are the main things that we have to look at here? This is going to be the equals method. This is going to be for a class here, array container that is a generic, so it has a type parameter, E. And what it has is a single instance variable. array that is going to be an array of objects of type E. And as the booklet also recommends, you need to have a look at the main method of this class in order to understand what kind of behavior you're expected to perform. When we do so, what you see would be a bunch of test cases that would give indications of what the implementation of equals is supposed to do. One thing that might be a little bit different, and I suggest you spend a little bit of time practicing for this, is that when you do testing in front of a computer, you may not really take the time to look at these test cases. You know, a lot of fancy stuff happens, and at the end, you know, if you consider the JUnits that you have, you know, lots of things happen, and you're told whether the output is the same as what is expected or it's not. Okay, this looks a lot easier than what it is when you have a paper-based exam. In particular, what happens is that you have to be able to read these test cases and understand what is going on. Okay, so do not be intimidated by a number of test cases like this. At the end of the day, what they're trying to show you is how, in this case, the equals method will be performing over different inputs. And if you're unable to basically walk your way through this and find your way through these instructions, you're not going to be able to understand what you're supposed to implement. Okay, so let's spend a little bit of time on this to make sure that we are all on the same page. So what the main method does here is to provide a set of inputs. And let me see if there is anything important that we need to cover before we get into test cases, other than the encouragement that please look at these test cases for the test. No, that's pretty much it. So let's look at the test cases. What do we have here? We have a bunch of inputs. So these are the various inputs that we have here from numbered from 0 to 6. So what you see here is that you are creating different instances of array container, and the goal of the equals method is to do a comparison of two instances of the array container class. So one thing you have to keep in mind is that there is a very sharp distinction between an array container that is null. Basically, you haven't instantiated an array container, and an array container that has been instantiated, but which has a null array inside it. Okay, so what we are going to see in the implementation of the equals is extremely similar to what we saw in class when we were doing the equals method for whatever class we had. It was a count or something else. I don't remember anymore. It's going to be following the same recipe. The only thing that we have to pay additional attention to is the fact that the array itself, it's both a reference variable. So we have the same kind of concerns that we have about any reference variable. Basically, we cannot do anything with it when it's null, but also past us checking whether it's not whether it's null or not, and if it happens to be not null, this is going to be a container of elements. Okay, so every one of these elements that we have in the array, they could be null or they could be pointing to something that is an object, an actual object. Okay, so this introduces a little bit of complexity, because what we had in the example we saw in class, account, for example, there was no intermediate level. There was basically, we had reference variables. It was not the case that the reference variables kind of had embedded in reference variables in them. For arrays, this is a different kind of situation because embedded in that array, you have a bunch of other reference variables. Okay, so your recipe is going to be the same with the additional step that you have to also take care of the array variable itself, not only the contents of the array variable. Okay, so you have these different possibilities. So what do we have in our test cases? If you compare input 0 with input 0, you're going to be expected to produce true. So basically, the array that you have is going to be the instance of the array container is existing, but the embed, what you have inside, the instance array that you have inside, namely this one, is going to be set to null. Okay, so if both arrays are null, then you expect to have true. Okay, this is not the same as having two variables, array 1 and array 2 here, which happen to be null. These will not be null, but the array they contain is going to be null. Okay, so that's one test case. The other test case is going to compare inputs 3 and 4. So the expectation here is that we're going to get true as well, because these two arrays, they have the same number of elements in them, and the respective positions in the arrays are matching. So position 0, A, both have A, position 1, B, both have B, and position 2, both have C, and all matches up. Okay, what else have we got here? The third test case is input 0 and input 1. Let me clean up this place a little bit so that it doesn't get too busy. Input 0 and input 1. So here is input 0, here is input 1. What question?
For the test case zero, you say that doesn't mean that I will run on my equal like
Yeah, because we have new. Yes. You are instantiating array container, but you're providing a null argument, which means that you're going to say in the constructor, this dot array equals null. So the array that you contain, you're an array container, you contain an array, that array is going to be null, but the array container itself is not null. Okay, so back to what we were discussing about input 0 versus input 1. There is a difference, again, between the array being null and the array of objects of type E inside array container, and the array having a number of elements which happen to be null. Okay, so in the first case, the array will not exist. In the second case, you have reserved the space for the array, in this case, an array of size 3, but you have not set the individual elements that you have in the array to point to anything. So array at position 0 points to null, array at position 1 points to null, array at position 2 points to null. Okay, so there is a distinction between the array inside the array container being null and the array not being null, having a number of elements, and those elements being null. Okay, and the list goes on. So in this case, you expect to get false. What else have we got? 4 and 5. 4, this is 4, this is 5. So obviously these will not match. You want to get a false here as the output of the equals method. And what else? We have 4 and 6. 4 and 6, in this case, Yeah, this is a good one. 4 and 6. What is interesting here is it, yes, 4ABC and 6AB. What is interesting is that one of these arrays happens to be a prefix of the other one. Okay, so one has AB, the other one has ABC. Obviously, these are not equal, but it brings a subtle point to attention. And that point is that because we are going to do this pairwise comparison, iterating over the elements of either the first array or the second array, either the elements of this dot array or the elements of other dot array, as we will see in the equals method, we're going to iterate. And we have to be careful that if the arrays, the underlying arrays for me and this other thing, this other array container, if they have different lengths, if one contains 3 elements, the other one contains 2 elements, then these arrays could not conceivably be equal. Okay? We have to be careful because if we write a for loop that happens to go over, the elements of input 6, and then it checks, okay, A is equal to B, A is equal to A, great, B is equal to B, great, and then it stops and it comes out and thinks that everything is okay. But in reality, this other input 4, has an additional element that we just glossed over. So we have to be careful with the lengths of the arrays. Okay? So we went through all that. Why? Because I wanted to give you a feel for how to read these test cases if you have something similar and understand the behavior that you're supposed to implement. Any questions? No questions. Great. So let's get down to it. I should have some template code here. Let me see what I've got. Yes. So basically, these test cases that we went over are here, but be careful when you do this on a computer. It's easy. You look at the outputs. At the exam, this is not going to be the same. Okay? Now, what are we going to do? You're going to basically do the same thing as we did before, following the exact same recipe. So one thing that we did in that recipe was to have this result set to true, and then we had a bunch of if-then else's going through all the reasons that two things would not be equal, and then set the result to false if any of those reasons held. And at the very end, we would return this result. Okay? Just to make things a tad bit simpler to read, I'm going to basically not carry that result with me through these if-then else's. Instead, I'm going to return false the moment I realize that my array, this dot array, could not conceivably be the same as this other thing, dot array. Okay? So I will not beat around the bush and carry this, going through all these if-then else's. The moment I know it's behaviorally exactly the same thing, it just makes us write a little bit less code and do not get caught up in a lot of else-ifs. Okay? So same thing, but what you have to realize here is that when you return in an if, then you do not have to say else if for the next if statement. Why? Because by virtue of returning, you are stopping the code from going any further into that method. So you don't need an else anymore. So let's start and replicate the same recipe that we saw previously. Okay. Can somebody tell me what the recipe said? So what was the first step of the recipe? Exactly. So we do exactly the same thing. If O is null, so instead of defining that result and carrying it through all these blocks, I'm going to simply return false. Not worth it. If O is null, I know that I'm an array container. This is, quote unquote, this is not null. Otherwise, this equal method would not have been invoked. So at this point, I know that I'm not null. Clearly, I could not conceivably be null. And if this other thing that I'm supposed to compare against is null, the answer is very clear. We're going to return false. We could not conceivably be equal. Can anybody remember what the next step is, according to the recipe? Exactly. So this would be our first, our second step. If this dot get class is not the same as this other thing, get class, I'm going to return false. Okay, that was our second step. Does anybody remember what the third step is? Exactly. So now, what have I done? I have made sure that O is not null. I have made sure that O has the same runtime type as I do through this if. And now that I haven't returned here, I can be sure that at this point on line 18, I can safely typecast this object O as an array container. So that's what I'm going to do. So array container other equals array container what happened? Did I miss a bracket? Yes. Array container O. Okay. Just a quick clarification here. If you do something like this, this, for the purpose of the exam, this was perfectly acceptable. This is not how it's supposed to be done because Java doesn't have any understanding of these parameter types at runtime, and this is not valid. But it's not something that we want to focus on. I already showed you when we were looking at this when we had a stack of integers and a stack of strings, or I don't remember exactly what class it was, but the point was that when you check whether these things, an array stack of integers, an array stack of, let's say, strings, they have the same type, Java will tell you that, these are the same runtime types, okay? So because of that, we do not need to bother with this, but, this was an extra point that would not have any impact. So if you say this is, it shouldn't be like that, but this would not have resulted in any marks to be deducted. Either you have to say it like this, which is very, very natural, or if you're wondering about what this type parameter is supposed to be, this is also a possibility, having a wildcard question mark, but this is not something that you were expected to know, and you will not be expected to know if you have something similar, okay? This works perfectly fine, okay? So the simplest thing works just the way it should. Now, we have done our cast. What this allows us to do now is to look inside, and that means that we know that there is now this array reference variable inside the array container. Okay, so what are we going to do? What you have learned, the recipe is going to be exactly the same. We are looking for excuses to say no. Otherwise, at the very, very end, you're going to say yes. So let me put this at the very, very end. So if all goes well and we find no excuse to say no, we are going to say yes. Okay? The question is what we're going to be writing in between. Okay? Now, the recipe also applies to array. Okay? Before we get into the nitty-gritty of what we have in the array, because array is containing a bunch of references, a bunch of pointers to objects, and we have to check the equivalence of those objects pointed to by the arrays. But before getting there, because array itself is a reference variable, we have to do the very same checks that we would do for other reference variables. What did we do for other reference variables? What we did was to check if one is null, the other one isn't null, then we would know right off the bat that the answer has to be false. Okay, so let me start with those. If this dot array is null and other dot array isn't null, return false. The dual to this would be when, let me just copy paste, if this dot array isn't null and the other array is null, I'm going to return false. Okay? Now, what else do I need to check? What other factor do I have that needs to match before I get into a pairwise comparison of the elements in this dot array and other dot array? Exactly. So I have to check for the size, the length. If I have different lengths, then I would say right off the bat, without getting into the array components, the array indices, that I could not conceivably have two arrays that have different sizes, and yet they are somehow equal. So that's going to be my next check. So I would say if this dot array dot length equals, rather doesn't equal, other dot array dot length, then I'm going to return false. Now, you write this, and then we have to think. Have we completely closed the door on the possibility of getting a null pointer exception? Here, on line 29, on line 29. Could it be that we somehow pass all these checks, we are here, and somehow we end up getting a null pointer exception? Exactly. So my goal was to check for discrepancies. Right? I did that pretty well. But the thing is that if I am doing something with this dot array or other dot array, invoking a method or trying to access a variable, I have to have made sure that, you know, the array, either this dot array or this other dot array, I have to have made sure that both are non-null. Now, as your classmate said, imagine you have both of these arrays as null. Basically, this dot array is null and other dot array is null. What is going to happen is that you're not going to return here. Both are null. You're not going to return here. Both are null. And then lo and behold, because at least one of these, because both of them are null, you're going to get a null pointer exception right here. Okay, you're trying to access length, and that array happens to be null. Okay, so what should I do in order to avoid this problem? Exactly. So before getting into any of this, once I have done this typecast, I'm going to have an extra case, and this looks a little bit different. So everywhere we are looking for excuses, but because somewhere further down, the prerequisite for us to look at that particular excuse is that these two should not both be null. Then you're going to have this exceptional case where we're going to return true very, very early. Okay, so what am I going to say? I'm going to say if this dot array is null and other dot array happens to be null, then I'm not going to return false. Instead, I'm going to return true. Okay, what does it say? It says that if both are null, then there is no point going further on. But in this particular case, I'm going to be able to say that, yes, I have two array containers. Both have null arrays in them. And then the result is going to be false, true rather. Okay. What am I going to do afterwards? Exactly. Well, I think we've already done that. Yes. So we did this first, and then from this we inferred that we had to do an additional check, which we did as well. What would be the next step? Exactly. Yeah, absolutely. Yes. So you could merge those. It's just that the condition is going to get quite bad. Yeah.
Well, or you would also accept if this array is not other array is not
What or let me see if I understand what you mean by or. These two, they can be merged.
Oh, okay.
I'm talking about these two. Yeah, you could. Well, it's the same thing, because logically speaking, if this holds or the other one holds in both cases, so you just have to. Yeah. Yes. So as your classmate correctly said, we have to now get into a pairwise comparison of the elements of the two arrays. This dot array and this other thing, dot array. And at this point, we know that the lengths are equal. So it doesn't matter whether I'm iterating over the elements of other dot array or the elements of this dot array. So I'm going to iterate over the elements of this dot array, knowing that in either case, we are going to have exactly the same number of iterations because this dot array dot length is equal to other dot array dot length. So what am I going to do? I'm going to say for int I equals 0, I less than this dot array dot length. You can obviously drop this wherever you want. This is just for clarity. In this particular context, I mean, because we don't have a parameter, a formal parameter named array. And then I++. Okay, so now, what is the recipe for inside this for loop? you are in the business of comparing reference variables. Why? Because you can look at every array cell as a pointer to some sort of an object. You know that it's going to be an object of type E, with E being a type parameter. So all we need to do is to replicate the recipe that we previously saw. Can somebody tell me what that recipe was? It was a two-step recipe. Other element is not null, then you would say false. Is not null. No. If this element is not null, then you have to delegate the rest to the equals method of the object. Okay, so you got the first part right. Let me write it down, and then somebody can help me out with the second part. So I would say inside this for loop, if array at position I, it's this dot array at position I, I'm not going to, let me remove it from here as well. It's not that it makes any difference, but, just for readability. I'm not quite sure whether, having the longer thing is more readable or like this. You can take your pick, obviously. If array at position I is null and other dot array at position I is not null, what am I going to do? I'm going to return false. Now, I've got one more if here, and let me do the outline, and somebody can help me out with what I'm going to put in there. Return false. You got the first part of this correct. So it is if array I is not null. What is left is the second part. I. Uh-huh. 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 And exclamation mark before, because we're talking about this not being the same as the other one. We are in the business of returning false. And not array at I equals other array at position I, then I'm going to return false. At the very, very end, we're going to return true. Now, let me see if I got this right. Well, let me see if it compiles. We don't know whether it's right or not. Java C, start.java. Well, that was surprising. Java, I didn't make any typos. Java array containing. Okay, true, true. The rest are false. So let's see what we had as our expectation. True, true. And the remainder would be false. Okay, so at least our implementation passes these tests, but conceptually, hopefully, this is also correct. Now, before I move on to the next question, and of course, ask you whether you have any questions about this, let me tell you how much each part was worth. So, just to encourage you to write something, every year, I see people who leave, the answer blank. And I'm quite puzzled because, as you will see, a fair bit of the mark is for things that you just need to be able to replicate based on what you have learned. So just to tell you that, a lot of the marks, some of it will require additional expertise. You have to basically adapt what you've learned to what you see, but most of it actually comes for free if you have studied well. So this thing is worth half a mark. The get class, this is worth another half a mark. This typecast is worth how much? This is also half a mark. These two together, basically checking if one is null and the other isn't, these two are worth collectively, both arrays are null. Wait. What am I looking at? No, forget about. So this is half a mark. So I was referring to these two. These two, checking one being null, the other not being null. These two would collectively be worth 1 mark, excluding the possibility of both arrays being null before we get to a comparison of the array lengths. This would have been worth half a mark. The array length, let me see how much. The length would be different array sizes. This would be worth a mark. Where is it? Different, yes. So this would be worth a mark. This did not, of course, have to be implemented in exactly the same way. There are other ways of dealing with this. This could also be done through the for loop if we are careful, but it has to be checked one way or the other. Then what else? We have one mark for the for loop, just getting the idea that we have to iterate and do pairwise comparison. And then 2 marks for this whole recipe applied. So basically for this whole recipe applied to array at position I instead of a reference variable named, I don't know, last name or something like that. It doesn't really matter. Any reference variable, the recipe is going to be the same. And then surprisingly, even the return, this single line there has marks. So you getting this single line right is worth as much as half a lab. Okay, so please spend the time to study well because, the midterm, the final, they have significant weights. Now, let me make sure that this adds up to 7.5. Otherwise, I will have got something wrong. So this is 1, 1.5, 2, 3, 4, 5, 6, 7, 7.5. Good. Questions?
So each level of code is decided to be like, because I really like it's not complex, but for yesterday, I was like, I've learned of one which is like comparing this other idea and this idea. Like, even if I have each level that I will go for a first level before you do one, but if you just know what you do.
In general, you don't have a, a combination effect. It's not that you have to think about the Cartesian product of all these possibilities because there is no nesting. So you don't have to think about how many reference variables you have in a given class. The recipe is going to be sequential. It's not that you have to think about all the possibilities. You look at the variables one at a time. In this case, the complexity arises from array being a container in its own sense. So previously what we saw was an instance of a class containing instance variables and instance methods. Here you have this array also acting as a container in a similar manner to an instance of a class. Okay, this is what makes it complex. I would, it's a good idea to do, these truth tables and, the combinations. If you have a reasonable number, again, they can get out of control if you have, 5, 6 things to take care of. Perhaps not the best way of doing things. Basically, in that case, the question was probably not a midterm question, so don't worry about that. This makes sense in the small scale, but it will not basically work if you have too many things that can be combined. And I would not recommend it for this particular question because there are only 2 levels, and you would get to it a lot faster by just thinking through the possibilities that you have. Any other questions about this equals method before we move on to the next question, please? It would have been easier. Why? Because you would still have to do all these things. Sorry, from here. Everything stays the same. What differs is that inside, you would not have to worry about null checks because the elements, the array can be null, that you have to check. But once the array happens to be non-null, if this happens to be an array of primitive ints, you know that every individual cell is existing and it's not a pointer, so it has a value. So you would check a simple, a value comparison. You will just do a simple value comparison. If this array at position I is not equal to other array at position I, then return false. It would have been a lot simpler because you would not have to resort to the equals method of whatever object you have, and you would not have to worry about nulls either. So this would be the same as, when we did this for the account, it had an ID and the name, one of the attributes, one of the instance variables was a primitive. So the recipe would be the same inside the for loop. Right? Any other questions? All right. Perfect. Let's move on to our second question. How much time do I have? I have until 5:30, right? So, yeah, we have enough time for this. Would not want to not be able to cover this. Yeah, yes. So this question is about stacks. Again, this is very unsurprising. It's usually like this if you look at the midterms from past years. And what does this question ask us to do? So this is about transforming a given integer, a base 10 number, into a binary representation with zeros and ones. So you take an integer n, which can be 0 or larger, and would return a string that represents that number in binary form. So now, this is something that you can probably do right off the bat without going over all the hints. What do? Intuitively, we divide the number by 2, and then we keep the remainder, and then whatever we are left with, we divide it by 2 again, we keep the remainder, and we go on and on until basically we're down to 0, and then what you get is going to be the result. in reverse order. And if you were not sure about how to do this, the hint, the conversion process, basically gives you the pseudocode. Okay? So last year, we were a little bit hesitant to not provide the hint in case, somebody cannot figure out the algorithm and, basically you're trying to quiz you on, on the Java programming, not the algorithm per se. So this implementing the pseudocode was all that was expected, but if you knew already what was supposed to be done, then you would not need that hint either. Okay? If this happens to be something simpler, there may not be any hint. So do not expect the algorithm to just be given there for you. If it's something very, very similar to what we've seen in class, I expect you to be able to replicate that. Okay? For example, this thing that we have seen over and over again on the command line, where we put things on the stack and then we pop things, and what happens is that we get things in the reverse order. Okay? You're not going to get a hint about the fact that one could do something like this with a stack. Okay? You may or may not get the hint, but it's not that you can expect it. Okay? So one thing that I also encourage you to pay particular attention to are the restrictions. If you see a restriction box, make sure you read through that first, even before reading through the question itself, because if you deviate, then you could forfeit the mark, the weight of the whole question. In this particular case, in this question, if you do not use a stack, basically no points would have been awarded. Right? Expect something very, very similar for your exam. If it asks you to do a stack-based implementation and you find an intelligent, elegant way of doing it, without a stack, no matter how intelligent your solution is, you're going to get a 0. So be very careful. What else does it ask you to do? You're not allowed to declare any new reference variables beyond what is provided. So basically, you look at the code, you see that the result, the string that is supposed to store the result has been defined. The stack that is going to be used for whatever algorithm you need to implement has been defined, and it asks you to not create any more reference variables. Okay? And this is very common. You're not supposed to be using any libraries whatsoever. Please do not waste your time reading up on, what kind of method we have in each class, even from Java land, past these methods that we have used over and over and over again. And, these things that you have seen in recipes like get class, you need to know what that is. Instance of, these things you, of course, need to know. Instance of operator, but, that get class is a good example of what you're supposed to know. But, getting into the minute details of, yes, a string had this split method and, it did this and that, and the format was like this, or, the regular expression I need to put to do the splitting is going to be like this. These are completely beside the point. So please do not waste time on that or trying to understand, what these different methods in whatever library you have in Java would do. There are no questions either on the midterm or on the final having to do with libraries. Okay? Don't bother. That's not one of the learning objectives of this course. So you have this piece of code and you're supposed to be implementing this algorithm. And there's also an example of what the output is going to be. For example, if you do this for 6, then you're going to get 1, 1, 0. Let me show you how the algorithm works. Actually, let me use another example. Let me maybe use 11. Just to give you an idea of how this is supposed to work. So n initially is 11. What we would like to do is to do n modulo 2, keep the result, store it on the stack, and then we are going to do n equals n divided by 2. So let's start and see what is going to happen. If it's 11, let me use a different color. So what is it going to be? N modulo 2 is 11 divided modulo 2. So this is going to be 1. And then 11 is going to be, n is going to be equal to n divided by 2. So n after this is going to be 5. Before I move on, I'm going to put 1 on the stack. So 1 goes there. And then I'm going to start the process with n being equal 5. What is going to happen afterwards? I'm going to have 5 modulo 2. This is going to give me another 1. And n is going to be 5 divided by 2, which is going to be 2. So my new n is going to be 2. My new n is going to be 2. What happens then? I'm going to do 2 modulo 2. This is going to give me a 0. The 0 is going to be put on the stack. And my n is going to be now 1. So it's going to be where am I? 2. So n equals 2 divided by 2. So n is going to be 1. So these go. And this is 1. What am I going to do now? I'm going to say the remainder is going to be 1 modulo 2. So this is going to be 1. I put it on top of the stack. And my n is going to now be 1 divided by 2, which is 0. And this is basically my stopping condition. Okay? Now, my number is going to be 1, 1, 0, 1. Why? Because this is 2, this is worth 2, this is worth, oh, sorry. This is worth 1, this is worth 2, this is worth 4. Where did I make a mess? This is 1, 2. Oh, yes. What am I doing? Yes. Sorry, yes. Yes. You start popping from the stack. So it has to, that's the, yes. So it has to be the first element comes first, then 0, then 1, then 1. And this is going to be 1, this is going to be 2, this is going to be 4, this is going to be 8. So this is 8 plus 2 plus 1 equals 11. Okay? And this is what the algorithm actually asks you to do. And if you look at this, place the remainder on top of the stack, and after the loop, the elements on the stack will be used to build the desired string. And you basically have the example here, how your stack is going to look like and what the output should be. Okay, so it will tell you that the output should, in the case of 6, should be 1, 1, 0. And then what you have on the stack from bottom to top is going to be 0, 1, 1, which basically tells you that, you're going to have to reverse this. Now, we have to write very, very little code for this. I might have actually inadvertently erased this template code that was there. So let me bring that back. stack. Now, while I'm on this, you see that we have linked stack here. As I told you, you do not have to worry about linked stack. But even in this, so last year, I didn't tell the class to not study for linked stack. But at the end of the day, the thing is that most of what we do with linked structures are ahead of us, is ahead of us. So I don't want you to worry about linked structures just yet. And the level of familiarity you need with linked stack on this exam was basically to know that it implements the abstract data type stack. And it doesn't really matter whether it's an array stack or a linked stack. But for what it's worth, you do not have to worry about linked stack at all. Even last year, all that was on the exam was knowing that linked stack is an implementation of the stack abstract data type. On your exam, you'll probably see an array stack. Okay? If there's a question on the stack, abstract data type, then instead of this, it's going to be something like array stack. Okay? Integer or string or whatever have you. Okay. Now, where was I? Yes, I have to bring this lost code back. And this I don't need. Open, where am I? Open binary converter. Now, you need to know what is in the stack interface. Let me open this up. So if you don't know the methods provided in the stack interface, you're going to be in trouble. So you have to know that you can check the emptiness of a stack, what push does, what pop does, and what peek does. Okay, that's something that you're expected to know. Otherwise, it will get tricked. Now, let me bring back the code that was erased by mistake. What do I have here? If n equals 0, then I'm going to return 0. And what else? String result is empty. And stack, the type argument is integer. Stack equals new linked stack integer. But I don't have the code for array stack handy in this directory. Otherwise, I would have, because I want to run it, it matters, what I put there. Otherwise, I would have put array stack integer, and then I would have had to provide a capacity, and nobody cares, what that capacity is going to be for the purpose of the exam. 100, 1000, it doesn't really matter. Right, so that's what I had in my template. Let me see if there is anything else. No, that's pretty much it. And now we have to write the code that does what that algorithm wants us to do. So what am I going to do? Exactly what we did manually. While n is larger than 0, I'm going to push n modulo 2 on top of the stack. I'm going to set n to n divided by 2. Integer division. So I'm going to say stack push n modulo 2 and n equals n divided by 2. That's all there is to the algorithm itself. Now we have to assemble our string. You can use this string buffer that we went over some lectures ago, but for the exam, don't worry about it. The problem we try to address using that string buffer was that if you say S plus equals, you know, some string, then you're going to create a lot of intermediate strings, or, you know, it could be S equals S plus, you know, comma. You're going to create a lot of intermediate strings, and this is going to negatively affect performance. If you want to avoid that, then use a string buffer, but you don't have to. And for the purposes of the exam, I encourage you to not do that at all. So string buffer, if you get into it, then know that you're going overboard. So I'm going to use a simple way of getting my output, and it's going to be stack. While the stack is not empty, what am I going to do? Result equals result plus what? Exactly. Okay. This is as simple as that. But there are some subtleties, you know, for one to get this simple piece of code, you have to think through some details. For example, I had declared my stack to be stack of integers. If I do something like that, how does this plus end up doing a concatenation? Can somebody tell me what happens internally? Does it have to unbox? No, it doesn't unbox in this particular case. What kind of integer do I have? Is it an integer object or is it an integer primitive? Okay. So what is happening here is that you're going to get string object back, the integer object back, rather. And this integer object is an object nonetheless. What do we know from the methods that we have in the object class? Every object has a toString method, okay? So it would only be wise for the integer class in the Java library to do a proper implementation of that toString method for the integer class. And you can expect it to be there. So it knows how to render a number as a string. So when you see this plus and you're trying to add a string to another string, Java knows that the toString method of whatever object comes out of this pop is going to be called. Okay, so essentially, this is going to be equivalent to this. And you could also say plus equals, but you know, you don't have to, well, if you say plus equals, you have to remove this, of course. It would have been even shorter, but you know, let's not overcomplicate it. You know, this is just as good. Now, let's see how this code works, and then I'm going to tweak the code a little bit so that it's going to do what basically get a command line argument and then transform that into a binary representation. So Java C, let me see if this compiles. Binary. It would of course be great if I returned something. So I have to return result. And Java binary converter. So what this does is to do all the numbers between 0 and 9. And hopefully the binary numbers are correct. What we want to do though is to, let's forget about what we have in here. Instead, I would like to say system.out print line. What is it going to be? It's going to be int to binary. I need to provide a number. What is that number going to be? It's going to be the first command line argument, but I cannot send this in like this because this is a string. So if I need an integer, I'm going to, was it? Yes, exactly. I'm going to say integer parse int. So this is for this, this is for this, this is for this. This should do the job. Of course, this is not the, while we were at that, let me, if args at length is 0, or args at position 0 is null, we stand out and line and out argument, and we are going to return. Otherwise, we are going to do this. Let's see if this binary. So if I say binary Java binary converter, this is going to say invalid argument, which is what I want. I didn't want to get a null pointer exception because I don't have an argument. If I say 1, this is going to tell me 1. If I say 11, this is going to tell me 1011. This is what we went over and agreed was the correct answer. And if I say stowaway, I'm going to get an exception. This is when we try to convert that number, parse this is stowaway, and turn it into a number, which we can't. And this is where we are going to get a number format exception. Okay. Now, before we call it done, in the 2 minutes that I have, let me just tell you how much each part was worth. These parts were given to you. So this while loop is worth 1 mark. The push is worth 1.5 marks. So 1 line, it's a lab and a half. And this is worth 1 mark. The loop is worth 1.5. This thing, I'm going to simplify. This is going to be 1.5. And returning the result would be 1 mark. So what are we left with? 1, 2.5, 3.5, 4.5, 5, 6, 6.5, 7.5. Right. Any questions? Perfect. So I'm going to be seeing you here on Friday, and we will practice for the multiple choice part. In the meanwhile, if you want to get a head start, the multiple choice part from last year is available on Brightspace, so feel free to watch it ahead of time if you want. Okay, see you back here on Friday.